The more examples, the better, so let's look at a couple more before we move on. In this equation, we have x over x plus 1 plus 5 over x equals 1 over x squared plus x. What we have here are three denominators. One of them is not factored, so let's factor it. My first one is x over x plus 1. X plus 1 isn't going to factor. Plus 5 over x. X is just by itself as well. But my third denominator will factor. It's got a common x in it. So take out the x and we get x plus 1. It's important to do that because then you recognize that this last denominator is made up of the first two. So when I go to create the LCD, the x plus 1 in the first denominator fraction, and then the second denominator has an x, together, when you put those together, that creates the third denominator. So the LCD, as the smallest thing it could be, is x times x plus 1. So we're going to multiply every single term by that LCD, x times x plus 1 over 1 times x over x plus 1, plus 5 over x times x over x plus 1 over 1 equals 1 over x times x plus 1 times x over x plus 1 over 1. So I've taken each term, multiplied it by the LCD over 1. Now the fun part, canceling. X plus 1's cancel. We're going to have an x and an x left. In the second term, I've got an x that cancels. And in my third term, I've got all of the LCD in the numerator and denominator that cancel. So make sure you write down what's left. We have x times x, or x squared, don't lose anything along the way, plus 5 times x plus 1 equals, and then because everything canceled on the other side here, we don't just have it go away. Remember, when you cancel something, there's a 1 left. So this is 1 over 1, or just 1 here. So we now have an equation without fractions. X squared plus, when I distribute, I get 5x plus 5 equals 1. Subtract the 1 from both sides, I get x squared plus 5x plus 4 equals 0. It's a quadratic equation, so factor. I have x and x. 4, well, two factors of 4 that make 5 are 1 and 4, so I'm going to use plus 1 and plus 4. Set each factor equal to 0. X plus 1 equals 0 means that I have x equals negative 1, and x plus 4 equals 0 means I have x equals negative 4. Remember to check all solutions. So when I check this first solution, x equals negative 1, right away I see that I'm going to get a 0 denominator, because when I plug that into the first denominator's fraction, I get negative 1 plus 1, or 0. So this is extraneous. Cross it out. It is not really a solution. It just happened to come up because of the technique we used. X equals negative 4, though, doesn't do that, so let's check it all the way. So plug the negative 4 in to the entire equation where you see x. So negative 4 over negative 4 plus 1 plus 5 over negative 4 equals 1 over negative 4 quantity squared plus negative 4. Carefully calculate the left and the right side. So on the left, I get negative 4 over negative 3 plus 5 over negative 4. Now a negative over negative is a positive 4/3. So 3 and 4 would have a common denominator of 12. To take that 3 to a 12, you'd want to multiply top and bottom by 4, so I get 16 over 12, plus, to change the second fraction to a denominator of 12, I want to multiply top and bottom by 3, so I get 15 over 12. And remember, that's a negative 15, so because that was a negative fraction, so 16 plus a negative 15 is 1/12. So I get 1/12 on the left side. On the right side, I have 1 over 16 plus negative 4. 16 plus negative 4 is 12. So 1/12 equals 1/12. That checks. So our solution was indeed negative 4.